All right, this is lesson 124 on rounding decimals. Like, just as a heads up, I really struggled when I was planning this lesson to say, like, what is the most, if you only have one day on rounding decimals, what is the most important thing to do? And I landed on what our kids really need right now is just a procedural fluency with how to round. So instead of like prioritizing the conceptual understanding, if we only have one day between now and the park, let's just make sure that 100% of our students are fluent with the procedural understanding. We will cycle or circle back to the conceptual understanding later. It's just important right now that like what the majority of kids are missing is like these like little tricks and doing a big day on conceptual understanding of rounding is not going to remediate those mistakes. That said, I did include some like conceptual questions about rounding. Like this is where I wanted to start, right? But this is now going to be in the independent practice towards the end, right? So like thinking about rounding on a number line, like why would we round up when a value is 5 or more? Why would we round down when it's less, right? Other things that our kids are missing. I mean, like the conceptual understanding here is like some of our kids are still, when we round this number to the hundreds, they're writing 8 and not 800. And so some of the questions that I need us to clarify for kids, I included as their like right pair share. Like, how do you know when to round up or down, right? And so I included some in part A, B, C, and D. I included one where it's like a 4 and we round down, and one where it's a 5 and we round up. This is also something that students should already know. The next question is like, why are we able to drop, quote unquote, the digits to the right of the rounded digit in part B, but not in part C? So if we look at part B and part C, like part B, the digits to the right are decimal digits. Like they're fractions of a number, they're not wholes, right? And here, the digits to the right are, 2 of them are whole numbers. So we have to like those become zeros. So some students are still missing that. Then the third question, how do you know if you have to change more than 1 digit? Which is this last part that kids are still struggling with when you have to like round up a 9 and we have to change more than 1 digit, right? So I am identifying some major misconceptions here in these first 4 like practice problems. You're going to model this and students are then going to write their responses to those 3 questions below, okay? We always say like, we're identifying right now, we're rounding to the nearest 10th. So the 3 is in the 10th place. Let's underline this. Let's look next door. This is 4. So it's less than half of the next number. So I get to round down. So this is approximately 84 3/10. Okay, let's look at the next one. I'm rounding to the nearest whole number. Whole number means ones. Why don't we go ahead and write that in, ones. So if I'm looking at this 4 and I look next door to the tenths, I have 7 tenths. 7 tenths is really close to the next whole number. So I'm going to round up. When I round up, this becomes 65. The 4 bumps up to the next digit. And then we drop the digits after this decimal point, right? I don't need these digits anymore because it said to round to the nearest ones place. And then this is the ones place. However, part C, I'm asking students to round to the nearest hundred. Some things here is like, I'm not rounding to the nearest hundredth, I'm rounding to the nearest hundred. So let's go ahead and make sure that we identify the difference between hundredth and hundred. I underline the 7, I look next door, this is a 5. So 5 or more, we round up. I'm rounding up to 8. The next digit is an 8, but I can't just leave it as an 8 because 8 isn't anywhere close to the value of 754. This is actually, this 7 represents 700, so now I'm rounding up to 800. The 10s in the ones place become a 0. I can drop the digits that were behind the decimal point, right? The 10s place becomes a 0, the ones place becomes a 0, so that this 8 actually represents 8 hundreds and not 8 ones. Then part D is where kids are really still messing up. This is, I'm rounding to the nearest whole number, so I'm going to underline 9, look next door, right? When I look next door, that's more than 5. I have to round up. What is the next digit greater than, or the next number greater than 9? It's 10. So that when that 9 gets rounded up, it becomes a 10, and that 10 is regrouped into the next place value position. So this doesn't just become 29, this is now 30, right? Because that extra that 10 was regrouped into the tens place. And then have students answer these questions, right? Like, how do you know whether to round up or round down? If it's 4, if it's a 0, 1, 2, 3, or 4, we round down. If it's 5, 6, 7, 8, or 9, we round up. Why were we able to drop the digits to the right of the decimal point? Because I don't need those to keep the place value of these digits, right? Like digits to the right of the decimal point, I don't need to keep in order to keep the place value of the whole numbers. However, I need these digits here to keep the place value of this 7 or that 8. And then how do you know if you have to change more than one digit? Well, we have to change more than one digit if we're rounding up a 9, it becomes a 10, and so it's going to get regrouped into the next place value position to the left.